In this part 2 video, we're going to solve some problems about concave mirrors using mirror equation. Example problem number 2. A concave mirror has a radius of curvature of 20 cm. You place a 2 cm tall object 30 cm from the mirror. What are the image position and the image height? Okay, let's draw a ray diagram. So that's my mirror, concave mirror. It has a radius of curvature of 20 cm. So I'm going to draw the principal axis. Let's say it's the focal point. This is center of curvature. This distance is the radius of curvature from the pole to the center of curvature, r. And r is given 20 cm. If r is 20 cm, then focal length is half of 20, r by 2, that is 20 by 2, 10 cm. So focal length is 10 cm. This point is 10 cm. This should be the double, 20 cm. Now we are placing the object 30 cm from the mirror. So my object is somewhere here. The height is 2 cm. Height of the object is 2 cm. And the object distance is 30 cm. This is XO. XO is 30 cm. In our coordinate system, up is positive, down is negative, right is negative, left is positive. So all the quantities we measure from the pole to the left is going to be positive. So focal length is positive because we measure it from the pole to the focal point. It's in the positive direction. So focal length is positive. This is positive. Radius of curvature is also positive. It's from pole to the center of curvature. Object distance is also positive from the pole to the position of the object. The distance is XO. So that is positive. Height of the object is positive because we measure it upwards. That's positive direction. So everything is positive in this case. Let's solve it. We're going to apply the mirror equation. 1 by f equals 1 by xi plus 1 by xo. Focal length is given. We need to find xi. Xi is unknown. So is image height hi. We need to find xi. So 1 by f minus 1 by xo is equal to 1 by xi. Put the values in. 1 by xi equals focal length is 10 cm minus object distance is 30 cm. Cross multiply it. 30 times 1 is 30 minus 10 times 1 is 10 over 10 times 30. Or 30 minus 10 is 20. 20 over 300. That is 1 over xi. So how do you find xi? Just flip it. 300 over 20. Which is 15 centimeter. We will get an image 15 centimeter from the mirror somewhere here. That's obvious because if you place an object beyond C, you should get an image between C and F from the ray diagrams that we have studied. Yeah, our image should be inverted, smaller in size compared to the object. Yeah, now let's find the height of the image. We're going to use the magnification equation. Hi over Ho is equal to minus Xi over Xo. Height of the image is unknown. I'm going to keep it like that. Height of the object is 2 centimeter. Image distance is 15. We have a negative sign here, so 15. Object distance is 30. Let's cross multiply. Hi equals minus 15 times 2 over 30. Minus 30 over 30. Minus 1 centimeter. This negative sign indicates that the image is inverted. It's a real image. The image is formed in front of the mirror. So if you place an object of 2 centimeter height 30 centimeter in front of a concave mirror, you'll get an image of height 1 centimeter, a real and inverted image 15 centimeter from the pole. Practice problem 13. You place an object 36 centimeter in front of a concave mirror with a 16 centimeter focal length. Determine the image position. Okay, let's draw the diagram. Focal point, center of curvature. We're going to place the object 36 centimeter in front of a concave mirror with 16 centimeter focal length. Focal point is at 16 centimeter. Center of curvature should be double that distance, 32 centimeter. We're going to place it at a distance of 36 centimeter. So our object is here. Okay, we're placing the object beyond C. So we should get the image between C and F. So our answer should be between 16 centimeter and 32 centimeter. That should be the image position. It should be somewhere between C and F. The image should be inverted and real. Okay, let's solve it. Let's use the mirror equation. The focal length is 16 centimeter. We are measuring the focal length from the pole to the left. That's positive. So plus 16 centimeter, that's the focal length. Now the object position should be positive as well. We're measuring towards the left. So 36 centimeter plus 36 centimeter, that's xi. Sorry, xo. Let's find xi. Use the mirror equation. 1 by f equals 1 by xi plus 1 by xo. 1 by xi equals 1 by f minus 1 by xo. 1 by f is 16, xo is 36. Cross multiply 36 minus 16 over 16 times 36. 36 minus 16 is 20. 16 times 36 is 576. That is 1 over xi, but we need xi, so we need to flip it. Xi is equal to 576 over 20, 28.8 centimeter. We got a positive answer. That means image has to be on the left hand side or to the left of the pole. 28.8 centimeter. This is 16 centimeter. This is 32 centimeter. So the image should be somewhere close to C. Yeah. That's 28.8 centimeter. Image should be inverted and real. Real and inverted. You place a 3 centimeter tall object 20 centimeter from a 16 centimeter radius concave mirror. Determine the image position and the image height. Concave mirror. This is pole, focal point, and center of curvature. Height of the object is 3 centimeter. It's positive 3 because you measure it upwards. It is placed 20 centimeter from a 16 centimeter radius concave mirror. Radius of curvature is given. This distance is equal to 16 centimeter. So this point is 16 centimeter. This point should be 8 centimeter because focal length is just half of radius of curvature. It is 16 by 2, 8 centimeter. This distance is the focal length, and that is equal to 8 centimeter. You're going to place an object 20 centimeter from the pole of the mirror. So I'm going to place the object here beyond C. This point is 20 centimeter, and this distance is the object distance xo. It's equal to 20 centimeter. Focal length, radius of curvature, object position, everything is towards left. That's our new positive axis. So all of them are positive. XO is 20 centimeter. All of them are positive. We need to find the image position and image height. So we need to find xi and hi. To find xi, we can use the mirror equation. 1 by f equals 1 by xi plus 1 by xo. rearrange to find xi. 1 by xi equals 1 by f minus 1 by xo. Substitute the values. 1 by xi equals focal length is 8 centimeter. The object position is 20 centimeter. Cross multiply 20 minus 8 over 8 times 20. 12 over 160. So to find xi, I'm going to flip it. 160 over 12. 13.3 centimeter. So we got an image between C and F. 13.3 centimeter should be between C and F. The image is real and inverted. To find the height of the image, we can use the magnification equation. Hi over Ho equals minus Xi over Xo. Hi is unknown. Ho is 3 centimeter. Xi is 13.3. Xo is 20 centimeter. Cross multiply, Hi will be minus 13.3 times 3 over 20. Height of the image is minus 2 centimeter. The negative sign is because our image is inverted and real. A concave mirror has a 7 centimeter focal length. You place a 2.4 centimeter tall object 16 centimeter from the mirror. Determine the mirror height. So I'm going to draw a concave mirror, focal point, center of curvature. It has a focal length of 7 centimeter plus 7 from the pole to the focal point, that is focal length. F is equal to 7 centimeter. You place a 2.4 centimeter tall object 16 centimeter from the mirror. If this point is 7 centimeter, this should be 14. Center of curvature should be at 14 centimeter. So you're going to place the object beyond C, 16 centimeter. This is my object. It is placed at 16 centimeter. And this distance is 16. That is XO. We need to find Xi and Hi. Ho is also given. It's a 2.4 centimeter tall object. This distance is 2.4 centimeter. Ho. Let's use the mirror equation. 1 by F equals 1 by Xi plus 1 by Xo. We need to find the position of the image Xi. As I'm rearranging, 1 by Xi equals 1 by F minus 1 by Xo. Substitute the values. F is 7 minus 1 over Xo is 16. Cross multiply. 16 times 1 is 16 minus 7 times 1 is 7 divided by 7 times 16. 16 minus 7 is 9. 9 over 16 times 7 is 112. That is 1 over Xi. So to find Xi, we need to flip it. 112 over 9. 12.4 centimeter. So we'll get the image 12.4 centimeter from the pole in front of the mirror because we have placed the object beyond C. So we're going to get an image between C and F. 12.4. This point is 12.4 centimeter. Okay. The question is to find the image height. So we need to use the magnification equation. Hi by Ho equals minus Xi by Xo. Hi is unknown. Ho is 2.4 equals minus Xi, we got 12.4. Xo is 16 centimeter. So cross multiply. Hi equals minus 12.4 times 2.4 over 16 minus 1.86 centimeter. The image is smaller than the object as expected. Also, it is inverted because of the negative sign. And the image is formed in front of the mirror, so it's a real image. You place an object near a concave mirror with a 10 centimeter focal length. The image is 3 centimeter tall, inverted, and 16 centimeter from the mirror. I'm going to draw a mirror, concave mirror, principal axis, focal point, center of curvature. It is given the focal length is 10 centimeter, so this point is 10 centimeter. This distance is also 10 centimeter. That's the focal length. This point should be 20 centimeter. Image is 3 centimeter tall, inverted 16 centimeter from the mirror. So we have an image 16 centimeter from the mirror, that is between C and F. The image should be inverted because it's a real image. This point is 16 centimeter. So that's the position of the image, xi, 16 centimeter. It's positive because it's on the left hand side in front of the mirror. That's positive, xi. We need to find the object position and object height. Image height is also given. That's image height, hi. Hi equals 3 centimeter, but it's an inverted image, so -3. Height of the image is -3 centimeter. We're going to find xo and ho. So to find xo, we have the equation, mirror equation, 1 by f equals 1 by xi plus 1 by xo. Rearrange to find xo. 1 by xo equals 1 by f minus 1 by xi. Substitute the values. Focal length is 10 minus xi is 16. Cross multiply 16 minus 10 over 16 times 10. 6 over 160. That is 1 over xo. Xo should be 160 over 6. 26.6 centimeter. Now to find the height of the object, we can use the magnification equation. Hi over ho equals minus xi over xo. Height of the image is given. It's -3 centimeter. Height of the object is unknown. Xi is 16 centimeter. Xo is 26.6 centimeter. Cross multiply ho times -16 is equal to -3 times 26.6. Ho is equal to -3 times 26.6 divided by -16. Negative and negative gone. If you solve it, you'll get 4.98 centimeter, approximately 5 centimeter.